Okay, and hello and welcome to the second video in the vectors series of videos for Pure 1. In this particular video we're going to look at the magnitude and direction of a vector and how we calculate the magnitude and how we understand the direction of a vector using diagrams. Quite useful techniques for us. So the magnitude of a vector tells the size of the vector. The notation used in A-level maths for magnitude is the vector letter with two lines either side of it, or you should have had this on the text, the vector AB with the arrow and those two lines either side of it. And it's basically calculated using Pythagoras' theorem. It's really not that difficult. So if you've got a vector A in a particular direction, if you know how far across it is in terms of x, horizontal distance, and how far up it's going in terms of y, then to find the magnitude of this vector you just do x squared plus y squared. It's as simple as that. The direction of a vector is found by using trigonometry, and a sketch is really useful. Now the angle theta in this formula is the angle that the vector makes with the x-axis, and we normally say it's the positive x-axis. So if I have theta there, I want to find that angle, then I sort of think to myself, okay, what do I know at the moment? Well, I've got my adjacent, I've got my opposite, so tan of theta equals my adjacent, my opposite over my adjacent, and therefore theta is the inverse tan or shift tan of y over x. Okay, and that will give me the angle it makes with the positive x-axis. Now, unit vector is not something which is a big part of the course, but essentially it's, if I use a description, a unit vector in the direction of A is the vector in the same direction as the vector A, but with a magnitude of 1. So if you've got a vector A going in a particular direction, then the unit vector is literally a vector going in the same direction, but it's got a magnitude of 1. Okay, and it can be calculated, and it's got this special symbol A with a little hat on it. We calculate it by using the original vector and dividing it by its magnitude. So if we know what this vector is and divide it by its magnitude, you can get these segments, which is what we call the unit vector. Okay, so let's have this question here. We've got this vector A, 12i minus 8j. We need to find the magnitude of it, the unit vector and the direction of A, and the angle it makes with the positive x-axis, and hence the bearing. So first of all, I'm going to do a quick little sketch. So 12i minus 8j, so 12 across minus 8 down. It's going to look something like that. Okay, so 12 and 8 down, and there's theta, okay, y and x. Now to find the magnitude, I'm going to use this symbol, magnitude symbol, and you literally just do Pythagoras. Okay, 8 squared plus 12 squared, 64 plus 144, square root that, and you got 4 root 13, and that is the magnitude of vector A. Part B, the unit vector in the direction of A. So the unit vector is given by a symbol and by this formula, A over the magnitude. So what we need to do is get the magnitude, which we already have, 4 over 4 root 13, and we've got to divide the vector A by that. Okay. Okay, and that is the unit vector. Okay, so the unit vector is given as such. Then we need to find the angle that the vector A makes with the positive x-axis. So again, what do I have here? I've got opposite and adjacent. So tan theta equals its opposite over the adjacent. Therefore, theta equals shift tan and get 33.69 degrees, which I'm just going to round to one decimal place. 33.7 degrees to one decimal place. That's the angle it makes with the positive x-axis. And hence find the bearing of A. Now, if you remember from GCSE, bearing is the angle that particular direction is from the north line. And in this context, the north line is the y-axis. So this whole angle here, this is the bearing that we need. Now, we already know what theta is. So to get the whole bearing, we need to do 90 plus 33.7, which is 123.7 degrees. And that's the bearing. Okay, so that's how you find magnitude and direction of a vector, and the exercise which you can use to practice these skills is down here.